Hello students, in this video I will be talking about the types of hashing techniques and their examples and types in detail. So this video is with the subject data structures and applications, the subject code being BCS 304. Okay, so I will be covering the fifth module topic, that is hashing. Under hashing, I'll be talking about types of hashing techniques in detail. So as you can see here, there are two types of hashing technique. One is static hashing, the other one is dynamic hashing. So in the previous video, you can go back and check in the previous video. I have explained what is hashing, what are the terms related with hashing, what are the hash functions that we use. All this we have seen in the previous video. So in this video, I will be specifically talking about static hashing and dynamic hashing and their types with examples. So what is static hashing? So look at the definition. A static hashing is a technique in which the hash table size or the bucket size remains the same during compilation time. That is called as static hashing. See, when you are writing code, okay, or when you're designing a hash table, you will give the hash table size, right? That means, suppose I give the hash table size as 5, that means I can store up to 5 keys over here. 5 keys over here. Okay. And their indexes being from 0, 1, 2, 3, and 4. Now, if I want to include one more element, it is not possible in case of static hashing. Okay, so a technique in which the hash table size remains constant. That is called as static hashing. And I'll show you an example over here. See, I have taken an example, store the records 24, 93, and 45 in the hash table of size 10. Now, when you look at this, you should be able to draw the hash table like this. The hash table, it's a hash table, and it says the size is 10. So 0, 1, 2, 3, 4, 5, like this up to 9. This is how your hash table is going to look like. And one of the hash functions that we have, one of the hash functions that we have is using the division method, that is h of k is k mod 10. Okay, so we'll apply that. Here it is, I'll first find the h of 24, h of 24 being 24 mod 10. 24 mod 10 is how much? 4. But how did you get this? So you will have to divide 24 by 10. So 10 times 2 is 20. Okay, so subtract, you get 4. Your modulus operator will give you the remainder of the two numbers. So here the remainder is 4. So 24 mod 10 is 4. Likewise, you have h of 93. See, h of 93, which is 93 mod 10. 93 mod 10. So how do you do the calculation? So it is 93, then 10. 10 times 9 is 90. So if you subtract, remainder is 3. So this will become the result of the modulus operation. Okay. So I'll erase all the unwanted things. And next one is h of 45. So it is 45 mod 10. 45 mod 10 is 5. Okay. So this means that in the fourth index, I will have to place the value 24. So in the fourth index, I am placing the value 24. Likewise, in the third index, I am placing 93. And in the fifth index, I am placing 45. Like this. This is how the static hashing is carried out. So it may have its own set of advantages and disadvantages. So let us look at the advantage and disadvantage. So I have taken the most simplest advantage so that you can easily remember if they ask in the exam or if they ask in the campus placements. Okay. So what is the advantage of static hashing. See, the advantage is simplicity. See the statement, static hashing is easy to implement since the hash table size is fixed with no need for resizing or restructuring. You know that in case of static hashing, the hash table size remains constant. So because of that, you need not worry about, resizing or restructuring the hash table. This is comparatively simple. Now, what do you mean by restructuring? In other hashing technique, we will have to restructure. Okay. So in this case of static hashing, you need not worry about that. So if they ask you about the advantage, you tell that in case of static hashing, simplicity is one of the advantage. That is, you only have to fix the hash table size and you need not worry about resizing or restructuring the hash table. So what is a disadvantage? Disadvantage is also related to the advantage. You know that the static hashing hash table size remains the same. Now, what if there are more values and you want to insert into the hash table? See, if the hash table is of size 5, is if the hash table is of size 5 and you want to insert, let's say, 10 elements, is it possible to insert 10 elements into a hash table of size 5? It is not possible. It may lead to collisions or it might become very, it is not feasible at all. You can't put the values into a hash table, right? When the keys are more than the hash table itself. So this would lead to something called as collision. As the load factor increases, collision becomes more and more frequent, thus reducing the efficiency of this particular hashing table, the hashing that we are going to use. So are you clear with this? Is all we have in static hashing, and also you have to know the techniques. The techniques like linear probing and chaining, they make use of static hashing. So what is static hashing? Remember like this, as I say, put these things into your mind. What is static hashing? A static hashing technique is a technique in which while you design the hash table, the size of the hash table remains constant. It will never change. Now, what is the advantage? Advantage is its simplicity. That is, we are at the beginning itself deciding the hash table size. So you need not worry about resizing or restructuring your hash table. What is the disadvantage? Because we cannot do anything alteration to the hash table size, this might lead to collisions. And when there are too many collisions, it might reduce the efficiency of the particular hashing that we are going to use. Are you clear with this? So take a moment. You can explain this also in the exam. When they ask you explain static hashing, you can explain what is a static hashing, show an example for static hashing and explain its advantage, disadvantage, and tell where it is used. It is used in uh, linear probing, chaining, etc. Now let us look at the next one, that is dynamic hashing. Okay, it is exactly opposite of the static hashing. In static hashing, the hash table remains constant. The size of the hash table remains the constant. Whereas in case of dynamic hashing, according to your need, you can shrink or you can increase the size of the hash table. Okay, so look at this definition over there. It's not a definition. I have explained what it is. So this is a hashing technique in which the table or the bucket size is not fixed. It can grow or shrink according to the increase or decrease of the records. Are you clear? Here the hash table can increase or decrease based on the user's requirement. So what is the advantage? Obviously, it is scalable. So see, scalability, what have I given as the explanation? Dynamic hashing can adjust the size of its hash table based on the amount of data it is storing. This makes it suitable for applications where the amount of data is unknown or it is frequently changing. So when you don't know the exact size of the data, or the data just keeps on coming, or sometimes data is also getting deleted frequently, so you need not, sometimes you need not have that much of a hash table, that much big of a hash table, or you might have to increase the size of the existing hash table. So scalability is one of the advantages of dynamic hashing. What is the disadvantage? See, complex, this is Complexity is a disadvantage because we are increasing and decreasing the size of the hash table. There are some things that needs to be done. See, bucket splitting, directory management, and resizing. These three terms, when you do it in dynamic hashing, it will increase the complexity of your technique. So this will be like, if you want to do it manually, also it is sort of complex. And when you want to execute it as a code, also it becomes very complex. So that is the disadvantage of the um, dynamic hashing and application. So every time, again, when I usually do the videos, I always tell you should know where the real life application is, because someday when you become a engineer, you might have to know, you have learned all these topics in your theory classes, but when you want to apply it in real world, you need to know where that concept can be used. So in case of dynamic hashing can be used in database management systems to solve the problem. It is used for solving the problem of bucket overflow. It is especially used for dynamic databases where data frequently changes the size. In case of databases, lot of data is getting added and lot of data is also getting deleted. In such cases, when you want to, increase or decrease your size of your hash table, that is when you can make use of dynamic hashing. So what is dynamic hashing? So you can look at this particular information. Here I have included everything. So yeah. So what is dynamic hashing? A technique where based on the user's requirement, the size of the hash table can be shrinked or expanded. That is meant by dynamic hashing. What are the advantages? The advantages, because of it is flexibility to increase or decrease the size of the hash table, it is very much scalable. Okay. What is the disadvantage? Same thing. When you want to do an addition or a deletion of a record in the hash table, you have to look at so many factors. The factors in case of dynamic hashing being bucket splitting, directory management, and resizing. Because of these factors, right, your hashing techniques become complex. So that is a disadvantage. And if they ask you about the real life application, you can say that the real life application is in case of database management system. Why? Because in case of databases, data are getting added frequently and also getting deleted frequently. So in order to maintain the balance, you need some data structure that can, alter its size. So that time you can make use of hashing. That is dynamic hashing. I hope it is clear. You can explain this when they ask about dynamic hashing. Okay. Now we will look at the next part, that is types of dynamic hashing. Types of dynamic hashing. There are two types. One is extendable hashing. The other one is linear hashing. Extendable hashing, linear hashing. So I will explain both of them in detail. Extendable hashing is also called as a dynamic hashing using directory, and linear hashing is known as directory less dynamic hashing. So now you understand, in case of extendable hashing, you have something called as a directory. Whereas in case of linear hashing, you don't need a directory. Still, you can shrink or extend the size of the hash table. And let us look at the extendable hashing. See here, in case of extendable hashing, I think this you already understand. Here, a directory is used which grows or shrinks depending upon the data distribution. So, based on the data, the hash table size will increase or decrease. And these four terms play a very important role when you carry out extendable hashing. So first term being bucket, then we have directory, global depth, and local depth. I will read out the definitions and I'll try to explain it here. If you don't understand at this point, then we will do an example where you can clearly see how these terms are used and what are these. So buckets are, these are used for storing the hashed keys. Your keys will get hashed, right? You have these values that you want to store. The values are getting stored in the buckets. And for each bucket, there is something called as local depth. Okay, local depth. See, bucket means bucket is sort of a hash table only. Okay, but here what happens is you will have multiple buckets. In hash table, if you remember, there only used to be one hash table whose size is fixed. Whereas here, in case of bucket, you can expand the number of buckets, or you can, expand means you can have more buckets, or you can delete the number of buckets. So buckets are used for storing your hashed keys. And what is local depth? Local depth is a term that is associated with this bucket. Okay, and what does it mean? It is a parameter in case of extendable hashing that determines whether the bucket should be split or the directory needs to be doubled. So you will have a bucket like this, and for each bucket, you will have something called as local depth. Local depth. Okay. Likewise, you also have something called as directory. And with the directory, we have something called as global depth. Global depth associated. So let me read out what these directories are. Directories are used to store the addresses of the buckets as pointers. They are used for storing the addresses. Whereas global depth is represents a number of bits used by the hash function to categorize the keys. See, when I read these definitions, you might have the confusion what it is and all that. So we will do this as an example. See, uh, before I go to the example, okay, see here. See, suppose there is a directory, okay, directory, and I told you there is one term associated with the directory called as global depth. Okay, let's say the global depth is 1. These are integer values, okay. And you have buckets also. Let's say I'm having two buckets. One is bucket 0. Let's say bucket 1 and bucket 2. This is bucket 1. This is bucket 2. And I told you each bucket is associated with something called as local depth. So this can be 1 or this can be any number. It depends upon many parameters. Okay. So for example, now global depth is 1. Local depth of the bucket 1 is 1. Now you see here, when you want to insert some values, okay, you might see in this bucket 1, let's assume that I can fit up to 2 values. So let's say one value is 24, the other value is 32, and now let's say I want to insert one value called as 10. See, when I want to insert the value 10, I can't do that in bucket 1. Why? Because 2 is the size of that bucket. That means I can have up to 2 values. So 2 values are already filled, 24 and 32. Now, if I want to fill one more value 10, it will not be allowing because that will lead to a situation called as overflow. So when you want to handle this situation, so I can't include 10 in bucket 1. So what to do? Then you will have to look at this condition. When the local depth is equal to global depth, so here, when the local depth is equal to global depth, what are you supposed to do? Apply the bucket split. You have to split this bucket. Split means you will have to make this bucket into 2. Now, bucket 1 will get divided into 2. It will be split. And also you have to do the directory expansion. Directory expansion means this will be now expanded like this. And certain values also need to be changed. Okay, I'll explain this with the help of an example. But remember this, in order to handle the overflow, when the local depth is equal to global depth, you apply the bucket split and expand the directory. When the local depth is lesser than the global depth, apply the bucket split but keep the directory as it is. Suppose local depth is 1 and your global depth is 2. And in that case, the overflow has occurred. So you have to keep it constant. Directory, you have to keep it constant. But this one, you will have to split. B2 has to be split into 2 parts. Like this. I hope it is clear. You are getting some idea. We'll look at the example. So you'll be able to understand it better. Okay. So I'll remove all this contents. I think, wait, everything is getting deleted, isn't it? Okay. So I will explain this with the help of an example. So you will be able to understand. See, you will have to explain, you have to apply extendable hashing. That extendable hashing means using the directory to insert the values into the storage. So these are the values 21, 27, 11, 37, 24, 22, 17, 15, and 23. We'll assume the bucket size is 3. Bucket size is 3 means in the bucket you can have up to 3 values. Okay, now you will have to apply the concept of extendable hashing. See, first thing, when you get a question like this, in case of an extendable hashing, what you do is, okay, in the step one, you have to get the, binary numbers of each value. Each value as in you have to get the binary number of 21, 27, and so on. So we'll do that. Okay. So first get the binary number of 21. How to convert 21 into binary? So you will have to repeatedly divide it by 2. So like this, okay, it is 21 divided by 2. So 2 times 10 is 20. Subtract it and you will get the value 1. So this is your quotient and this is your remainder. So write quotient over here and remainder, put a dash and put the remainder like this. Likewise, again you do. So 10 is the value. So it will be like this 10, 2 times 5 is 10. Subtract it, you are getting the value 0. So write the quotient here and the remainder to the right like this. Again 5. So 2 times 2 is 4. Subtract it and you'll get the value 1. So the quotient is this and the remainder is 1. So quotient comes here and the remainder is 1. Okay. So 2 again. 2. So 1 times 2. Remainder 0. So quotient and remainder. So quotient will come here. Remainder is over here. Like this it will be. So the values will go from the top. Okay. So it will be 1 followed by 0, then 1, 0, 1. So it is 1, 0, 1, 0, 1. This is the binary equivalent of the number 21. Likewise, you will have to do for all the other numbers. Okay. So we'll do for all the other numbers. Meanwhile, you can also take some time and calculate the values. So for 27, the binary number is 11011. And for 11, 11 is actually 1011. 1011. But the idea here is, see, look at all the other digits. Okay, 21. 21 binary number is having 5 digits. See, 1, 2, 3, 4, and 5. Here we are having only 1, 2, 3, 4 digits. No. So you will convert that into 5 digits. So I'll add one extra 0 over here. Okay, we'll make all the binary numbers having equal digits only. Okay, likewise, 11 is done. Then 30. 30 is 11110. 7 is 00111. 24 11000. 22 10101. 27 11011. 11 0101. Hold on, I think I did a mistake here. After 7, we have 24. 24 is 11000. 22, 10110. 17, which is 10001. 15, 01111. And 23 is 10111. Okay. Once you have understood the conversion of any one decimal number to binary number, I think you can easily do for other numbers as well, right? Okay. Next is step 2. Here we will introduce the concept of local depth, global depth, directory, and bucket. So first is draw a directory. Okay, this is the directory. Mention its global depth. So I told you directory will be associated with the global depth. So global depth, I will write it as initially 1. Global depth is for the directory. Initially, the global depth is 1. What does this mean? This means that when you have 2 to the power, this you remember like this, okay, 2 to the power of n. So here the global n means the global depth. So 2 to the power of 1, 2. That means in your directory, you can have two sort of addresses, two addresses. See here. So I'll have directory with two addresses. So it is a binary number, right? We are converting the given decimal number to a binary number. So you have to write like that. So if it is two binary numbers, I can have 0 and 1. 0 and 1. Are you clear? 0 and 1. So for each of this, for 0, we will have one bucket. And for this, we will have one more bucket. For 1, we will have one bucket, and for 0, we'll have another bucket. Okay, so we'll give the local depth for each of the bucket. If you remember, initially, local depth will be same as the global depth. See, global depth is 1, so local depth is also 1. Now, what you're supposed to do is, okay, now what you're supposed to do is look at each of the binary numbers, identify its last bit, that is your least significant bit, whether the least significant bit is 1 or 0. If it is 1, place it under the directory whose address is 1. Okay, look at that and put it into that bucket, whichever it is pointing to. See, here the least significant bit is 1. In case of 21, the least significant bit is 1. So you will consider this directory because least significant bit is 1, and wherever it is corresponding, in that, you will place the value 21. Okay. So, I'll delete all the other contents. Okay. So, here it will be 21. Likewise, you will look at over here. See here, for 27, the least significant bit is 1. So, again, you will look at this one, and it is pointing to this particular bucket. So, here, where are you supposed to place that 27 now? 27 also will come here. Likewise, 11. 11 also will come to this position. Correct? Now, 30. Next one is 30. 30's least significant bit is how much? 30's least significant bit is 30's least significant bit is 0. So, it will correspond to this one and its bucket. So, 30 will come here. Likewise, 7. 7's least significant bit is 1. 7's least significant bit is 1. Okay, so 1 is over here. So ideally, the 7 value should have got placed in here. But if you look at the corresponding bucket, the bucket is already full. It says the bucket size is up to 3. So 3 values are already filled. Now, what is it going to happen? What is going to happen? it will lead to something called as overflow. So 7 will not be able to fit into this bucket and it will be an overflow. Are you clear with this? It will lead to a situation called as overflow. Wait. Okay, now what to do? If there is an overflow. Now, what you are supposed to do is, wherever the overflow has happened, I'll name this bucket as B1 and this bucket as B2. See, the overflow has taken place in bucket 2, right? Correct? Now you will have to split this bucket. So B2 will no longer be B2. It will become, the B2 bucket will be there, but B2 will be split into another bucket. It's like if you have a bucket like this, okay. See here, if you have a bucket like this, okay, what you do is this bucket will be there, this bucket will be there, but its remaining half part, okay, is again split. So if this total bucket is B, B will be there and its other part also will be there. It is split into two parts like this. Okay. So now what we will do is we will have three buckets now, right? So B1 will remain as it is because B1 did not have any overflow, right? So B1 will be as it is, whereas B2 will be split into two buckets. So B2 as well as B3, B2 as well as B3, like this. Now, what will happen here when you do this splitting? So, nothing has happened to B1, so its local depth is still 1. When you split here, when you split a given bucket, so directory also will have some change. What is the change here? See, initially, bucket directories, initially in this case, directory, its global depth is how much? Its global depth is 1, right? Here, its global depth is 1. Now what happens is when you split it, the global depth will increase to 2. So this will now increase to 2. And if you remember, I had told you, you have to remember this formula. So it is 2 to the power of 2. So you can have up to 4 values. Now I think you know digital design. So 4 values means it is, how can you place the values? It is 0, 0, 0, 1, 1, 0 and 1, 1. Right? Like this. Okay. Like this. Okay. Now, what one more change has to happen, that is when you increase the global depth, the local depth of the splitted buckets also will increase by 1. So this will be 2 and this also will be 2. Are you clear? Are you clear with this step? Let me explain again. See, when you did the, I'll explain from here. When the overflow occurred in the bucket B2, I have split that bucket 2 into two parts. So one bucket 2 will be there, then the other one is bucket 3. This B1, B2, B3, you need not write. I have written it so that you can understand it. In the test, if they ask, you need not write. In your mind, you should know that you are splitting B2. Okay, and when you do that, when you split a given bucket, its hash, the directory also will have a change. Its global depth will increase by 1. So if the global depth increases by 1, it is 2 to the power of 2. So 4 bits will be there. So I have written 0, 0, 0, 1, 1, 0 and 1, 1. Okay, and when you split, the global depth also will, the local depth will increase by 1. So I have written for B2 and B3, the local depth is 2. Okay. Now, what are you supposed to do? How to do the connections? See here, you have split this and this, right? So, this was split because of this value. So, see, bucket 2 was previously pointed out 2 by 1, right? So, wherever 1 is there, for that you do the connection. See, 1 is there at 0, 1. Least significant bit you have to look at. So, 0, 1. So, that I'll connect here. 1, 1 will connect here. Likewise, all the bits ending with 0 will go to this part. So the one which did not split, that is B1, is getting more than one connection, whereas the one which is split is getting uh, the one which has been split is only getting one connection. See, B2 only got one connection and also B3 got one connection. Correct? Now again, you will have to put the values. So, see, 2 bits you have to consider. Now you have to consider 2 bits. So from 21, I'll consider the last 2 bits. Last 2 bits of 21 is 0, 1. So 0, 1 is here and its bucket is B2. So I'll place 21 over here. Okay, so 27's last 2 bits are 1, 1. So 1, 1 means it will come here. Okay, 11's last 2 bits are 1, 1. So it will come here. And uh, 11 is okay. Then 30. 30 is having the last 2 bits as 1, 0. So 1, 0 is here. So 30 will come here. And 7 is having 7 is having 1, 1. So it will come here. Then we have 24. 24's last 2 bits are 0, 0. So 24. And 22. 22's last 2 bits are 1, 0. So 1, 0. So 22 will come here. And 17. 17 is having 17 is last 2 bits are 0, 1. So 0, 1 here. So it will come here 17. Then when it comes to 15, look at this 15. 15's last 2 bits are 1, 1. It has to come here. That means it has to come at bucket 3. But if you look at the bucket 3 is already full. So what is it going to lead? It is going to lead an overflow. It is going to lead to an overflow and the overflow value is 15. Correct? Okay, just a second. Okay, so now the overflow has occurred at B3. Now you have got an idea. Can you think what are you supposed to do here now in case of overflow? Overflow has occurred at bucket 3. So bucket 3 has to be split. Correct? And what will happen to the directory? Directories will have more values and the global depth of that directory will be increased by 1. Right now the global depth is 2. Now the global depth will change to 3. Are you getting the idea? So now write like this. The the directory, no hash table, sorry, directory. Okay. And increase the global depth by 1. So if you remember, it is 2 to the power of 3. So 8 values will be there. So it is 0, 0, 0, 0, 0, 1, 0, 1, 0, like this. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So this will be the 8 addresses. Next, we'll draw the buckets. Bucket 1 will remain unchanged, as in its local depth will still be 1. B2 also will remain unchanged. Its local depth is 2. Whereas B3 will be split into 2 parts, right? So this is B1, this is B2. B3 is split into 2 parts. So B3 and B4. That is why its corresponding local depth will increase. So 3 and 3. Okay. Remember, now how to do the connections? Remember, from 1, 1, we had the connection to B3, right? So anything related to 1, 1. So here, see, 1, 1. So this will come to this part. Okay, wait. So it will come here. And this one over here. All the connections to B1 I will represent in red all the connections to B1, sorry, wait, all the connections to B1, I will represent it with red, and all the connections to uh, B2, I will represent it with orange. Remember like this, okay? So all the connections to B1. So remember, first we'll do all the connections to B1. See, B1 is this line. Its value is 0, 0, right? So 0, 0. So this one is having 0, 0. Is this red? Correct, no? Yeah. And one more 0, 0 is over here. Correct? So it will correspond to this one. Okay. Next you see, this is having the value 0, 1. B2, 0, 1. So I'll take orange. So B1, sorry, B1 to orange. And 0, 1, 1 is here. Okay. 0, 1 to orange. What about the rest of the connections? Which connections are left out? This one is left out. And also this one. Where do you think this should go? Now this is 1, 0, right? So where do you think it has to go? One is 0, 0. The other one is 0, 1. So 1, 0 also will go to 0, 0 itself. So red color. So 0, 0. Which one is left out? 0. This one also will go here. And also 1, 0 will also go to this one. Don't get confused. Take your time and clearly go through this. Okay. Now, what is the idea? How to place the items into the bucket? So, you have to look at the 3 digits because here we have 3 digits. So, you'll have to look at the 3 digits. So, 21's 3 digits are 101. So, 101 is here. 101 will come to this bucket. So, bucket 2, 21. Next is 27. It's 3 bits. 011. So, 0 0, 1, 1, 0, 1, 1 is here. So this will be 27. Next you have 11. 11's 3 bits are, last 3 bits are 0, 1, 1, 0, 1, 1, 0, 1, 1. So it will come here. Like this, you will have to place the values. Okay. So after 11, we have 30. 30 is 110, 110. So it will come here. Then we have 7. 7 will have, it will come here because 7's last 3 bits are 111 and 111 is here. Likewise, 24. 24 is 000. So 24. Then 110, 22. So 22. 22 is 110 here. Okay. And 17, 001. 17. Then you have 15. 15 is having 3 digits, 111. So it will come here. And 23. 23 again is having last 3 digits as 111. So you will have to find out that address which is having 111 and whichever bucket it is pointing to, in that you will have to place the values. Like this. Are you clear? So we have placed all the values and there is no condition of overflow. So we can stop the solution over here. Are you clear? This is how you will carry out the extendable hashing. So take a moment, take a screenshot of this and then do this problem on your own and check if you're getting the answer. Okay. What if there was an overflow here? Suppose there was an overflow. Let's say there was an overflow and the value is 42. Then what are you supposed to do? If there was an overflow at bucket 4, then you will have to split bucket 4 into 2 parts. Okay, then bucket 4 would become B4 and B5 and also its local depth will increase to 4. So global depth also will increase to 4 and now your directory will have 4 bits each. This is how you will do the extendable hashing. Okay, I hope it is clear. I'll do one more example so that it becomes clear. Okay, I have taken the values 5, 6, 7, 10, 12 and 16. Now I will take the bucket size to be 2. See, before I took bucket size to be 3, now I will assume bucket size to be 2. That means I can place 2 elements into the bucket. So first, what is the first step? Find the binary numbers of the given decimal number. So 5 is 101, right? 101. Correct? 6 is what? 6 is 110. 7 is what? 7 is 111. 10, 10 is 1010. And 12, 12 is 1100. And 16 is 1 followed by 4 zeros. Now what you have to do, first thing, check if the number of digits in each binary number are equal or not. It is not, because you see in 16 we have 5 digits, whereas in case of 5 I only have 3 digits. So what are you supposed to do? Add zeros so that it becomes equal number binary numbers. Okay, so here I have only 4 digits. I'm having 1. Here also I'm adding. Like this you're supposed to do. Now let's do the bucket. Okay, so initially I'll call this as the directory, and its depth is 1. Global depth is 1. I'll have 2 buckets initially. 2 buckets, one for 0 and one for 1. Now I think you should be knowing what this is. So shouldn't be a problem in understanding what I'm writing here. So its local depth is also 1. Okay, I'll call this bucket as B1 and this bucket as B2. This is only for my understanding. You need not write it. Okay, next, take 1 digit each from the binary number and look at which directory it is, which address of the directory it is corresponding to, and wherever it is pointing, whichever bucket, you go and place the value over there. So its least significant bit is 1. 5's least significant bit is 1. So 1 is over here. It is pointing to B1. So you place, sorry, it is pointing to B2. So you will have to place 5 over here. Okay. So 5 will come to this point. Likewise, 6. 6 is the least significant bit is 0. So 6 will come here. Okay, then 7. 7 is least significant bit is 1. So 1, so it will come here. And 10 is least significant bit is 0. So 10 will come here. Okay, next is 12. 12's least significant bit is 0. But if you see, can you place another value? Can you place 12 over here? Is it possible to place 12 over here? No. Why? Because the bucket size is 2. Bucket size is 2. You can only have 2 elements. So 12 can't be placed. So what will it lead to? It will lead to a condition called as overflow. Okay. It will lead to a condition called as overflow. Okay. So 12 can't be placed. So 12 is the overflow. Is 12. So now what are you supposed to do? B1 has to be split into 2 parts. So here, when you split that, your directory also will increase. So initially it was 1 global depth. Now it will be 2. Because of 2, you will have element 0, 0, 0, 1, 1, 0, 1, 1. So overflow has occurred in B2. So you will have to split that bucket. So see here, B1 will be here as it is. Okay, so this bucket is split. Okay, so here. What about the next bucket. Should I place a new bucket or should I keep B2? Because here in the previous step, after B1, we have B2, right? So no need to worry about it. Just to place B2 over here. Whatever extra bucket that you get after splitting, that you can place it over here, B3, like this. Okay. Now, how do you do the connection? See, 0, 0 is where the bucket overflow has happened, right? So, 1 0 1 here it will connect, and the other 0 it will connect over here. So, the other two will automatically get connected to B2 itself. Now, what will happen to the local depth? So, this has been split. So, this will now increase to 2. Similarly, B3 also will increase to 2 and B2 will still be 1. Why B2 is still 1? Because B overflow has not occurred in B2. Okay, now we'll try to place the values. So you'll have to take the two values. So 5 is having last two digits as 0, 1. So 0, 1. So 5 will come here. 0, 1 is here, right? So it's corresponding bucket. Sorry, wait. Sorry, wait. One confusion over here. The idea is 0, 1 will now connect. You can't connect. Hold on 1 second, okay? Okay. What will happen here? This itself is see, 1 minute. Let me do the connections again. Okay. So 0, 0 is where the connections have happened. So connections. So this will be here 0, 0, and the other 0. It will come to this one. This is here, and this is also here. Correct. Okay, sorry. So first is 0, 1. So 0, 1, 5. 6 is 1, 0. 1, 0 is here. 1, 0 is 6. Okay, 1, 0 is 6. And 1, 1. See, 7 is 1, 1. So 1, 1. So 5 and 7 will come here. 5 and 7 will come here. Likewise, for 10, it is 1, 0. 1, 0. So it will come here. Sorry, not 7. It is 1, 0. 1, 0. Then you have 12. 12's last two bits are 0, 0. So it will come here. And 16 is also having last two bits as 0, 0. So it will come here. This is how you will do the extendable hashing. So the idea is initially keep the local depth and global depth to 1, and whatever bucket size you have, that you will have to draw it. But so at the very beginning, when you do the directory, so one directory is having two parts. One is for 0, the other one is 1. So for for the 0 bit, have one bucket. For the 1, you have one bucket, like that. Then you try to place the values. If there is an overflow in one of the buckets, split that bucket, increase its local depth. While increasing its local depth, also increase the global depth of the directory, and based on the formula of 2 to the power of n, place the values like this. You go on doing the extendable hashing. Okay. Next is the concept of directory less dynamic hashing. So here we have linear hashing under this. Here there is no concept of directory. The buckets are split in linear order. Okay, so the idea is given over here. See, pages are split when overflow occur, but not necessarily the page with the overflow. Directory avoided in the linear hashing by using overflow pages staining approach. See, the thing is when you, in the case of the extendable hashing, if you remember, when the overflow occurred, that overflow bucket was split, right? Here, when the overflow happens, the bucket with the overflow, not the bucket, the contents of that particular bucket with the overflow is not split. Something else is split. Okay, splitting occurs in turn in round robin fashion, one by one from the first bucket to the last bucket. Use a family of hash functions h0, h1, h2. Each function's range is twice of that of its predecessor. I will explain this. Okay, this will be very important in solving the problem. And when all the pages are at one level, the current hash function have been split, a new level is applied. These 2 points are very, very important. See, it says this one, no, hash function h0, h1, h2. See, initially h0, okay, it is whatever key you have, mod 2. Okay, next time when it becomes h1, okay, it is k mod 4. It will become the multiples of 2. 2 becomes 4. So, h2 will be k mod 8, like this. H3 will be k mod 16 and so on, like this. Okay, so we will take up one example. Carry out the linear hashing on the following keys: 8, 16, 5, 11, 4, 19, 22. Assume that you start with two buckets and the bucket size is 2 and the hash function h of k is equal to k mod 2. Show the table structure after each insertion and any bucket splits. We will do this. Okay, then you will be able to understand how linear hashing has been carried out. Okay. Okay. So we'll carry out the linear hashing on the keys. Okay. So what we are supposed to do is initially we will consider this round as the initial round. So I'll call this as round 0. Round 0. See, bucket size is 2 and there are two buckets. Okay. Bucket size are 2 and there are two buckets. So I'll write the two buckets. One bucket is, I'll name the buckets. So first bucket, I'll name it as B0. You can give any name. I have named it as B0 and B1. And you need one pointer. Okay, this pointer is very important. I'll call that pointer as next. Usually at the beginning, it will point to the very first bucket. Okay, this you have to do. And you know the hashing function is this. H of k is equal to k mod 2. Okay, so initially we are applying H0. This is the initial hashing function, H0. Okay, so what we are supposed to do is we are applying H0 function. I'll use a better color. So I am using the hash function H0. So I'll take H0 is H of k is k mod 2. That is the initial one. Okay, so initial is 8, right? The first element is 8. So 8 mod 2. 8 mod 2 is 0. Correct? So when you divide 8, so 2 times 4 is 8. Subtract 0. This is your quotient. This is the remainder. So remainder has to be written. Likewise, so when it becomes 0, this is the 0th bucket. Okay. So like how you had in the extendable hashing, here also 0 and 1 will be there. So all the values of 8 will go here. Oh, I mean of the 0. Okay. Next one is 16. So 16 mod 2, which is again 0. So 16 also will come to this bucket B0. Next is 5. 5 mod 2. I'm taking one value at a time from the question given. So 5 mod 2. So 5 mod 2. So 2 times 4, subtract 1. Okay, so this is 1. So this should come here, 5. Likewise 11. 11 mod 2. 11 mod 2 is 11 mod 2 is 1. So 11 also will come here. Correct? Then Next one is 4. 4 mod 2. 4 mod 2 is 0. So ideally it should come to B0th bucket. But can you place 4 in that bucket? 4 you can't place because there's an overflow. Right? Now what to do? This is important. Now what are you supposed to do? See, okay, these are the calculations. Okay, so what we are, this one is overflow one. So overflow has happened here. So I'll write overflow. The value is 4 that has caused the overflow. Now what you're supposed to do is increase, or you have to split the bucket. Okay, no. How do you split the bucket? See, you can't randomly split the buckets. What you're supposed to do is here, this pointer is there, right? Called as next. Wherever next is pointing to, okay, that bucket has to be split. Sometimes what happens is, see, overflow might have occurred at B0. E point you have to understand correctly. Understand this point correctly. See, overflow might have occurred at B0, but if the next is pointing to B1, B1 has to be split. Next, wherever it is pointing, that bucket has to be split. But for our, this coincidence, as you can see, splitting the overflow is also happening at B0, and the next is also pointing at B0. So B0 has to be split. Now, how do you do the calculation? See, so what you're supposed to do is B0 will be split. So now initially there were 2 buckets. Now it will become 3 buckets. So B0, B1 and B2. B0, B1, B2. Now what you're supposed to do next is, see, initially next was in B0. Now next will come to B1. It will come to B1. Also, see, B1, nothing has happened, right? B1 has not caused overflow. So here it will still be H0. Wherever the splitting has happened, there you will have to apply H1. H1 as in, now if you remember, there was one point here, see, every function's range is twice as that of its predecessor. So now H1 will be whatever key you have, mod 4. Mod 4. Okay, so in bucket 0, there was 8 and 16, right, initially. So on that only you will have to apply mod 4. Okay, whereas B1 is untouched, so I'll keep it like that only. Okay, I'll keep it as it is. But the other one you will have to change. Okay, so 8 mod 4 is 0. So no problem. I can directly place it over here. Then the other value that we had is 16. So 16 mod 4 is 0. So again 16 will come here. Then you had this overflow value, right? So 4 mod 4. So 4 mod 4 is again 0. But again 0 is a, that bucket is again overflow. So nothing to be done. Keep it as it is. So 4 is still an overflow even after splitting the bucket. Now what do you do? Overflow has occurred at B0, but which bucket would you split? You would split the bucket on which the next is pointing to. So what are you going to do in the next step? Now there will be 4 rows. One is B0, B1, B2 and B3. Correct? Let's. Okay. Now it will become like this. Correct? So B1 was split. This was the one that was split. I'll represent. This was the one that was split. So B0 untouched. Okay, B0 untouched. Now B0 is having H1. It's B2 is also part of it, so that will be H1 only. But now B1 was split, no? So that will be increasing. Its hash will increase. So H2 is K mod. Sorry, wait 1 minute. See here. Now the split has happened at which one? Split has happened at H0, right? I mean B1 bucket, right? So B1 was initially having H0. Now this will also become H1. So it has B1 was split into B1 and B3. So B3 also will have H1. Others anyways is having H1 only from the previous step. So B1 had 5 and 11. So on that you will have to apply mod 4. So it is 5 mod 4, which is 1. And here there's still an overflow. Don't forget, sorry. Don't forget overflow is still there here. Okay. Then you have 11. So 11 mod 4, which is equal to 3. So 1, okay. So place 5 here. 11 is 3. So B0, B1, B2, B3. So place your 11 over here. Okay, like this. Next, take the next element. So 8 is done, 16 is done, 5 is done, 11 is also done, 4 is also done. Next is 19. 19, correct? So how do you do 19? But before 19, see, once you have done this, okay, now where is that next pointer? Where do you place next? Ideally, so after B0, next was moved to B1. So you will assume that next has to come to B2, right? Next should come here. But that is not the case. See here, one point is there in the explanation. Can you see? When all the pages at one level have been split, a new level is applied. When all the pages are split, see, B0 also has been split to B3, B1 was split to B0 was split to B2, and B1 was split to B3, right? So everything has been split. Now what to do? Correct. The original ones were B0 and B1. They have been split correctly, right? So where do you place the next? Next will automatically come back to the first position. It will come back to the next first position. So now how do you uh, apply the function? See, okay, so H2. See, like this. Okay. Now what are you supposed to do? Okay, 1 minute. See, next is here. So wherever next is there, that you will have to do the splitting, right? So it will be B0, B1, B2, B3, and now B4 also. So like this it will be. Like this. Okay. Now automatically next will come here. So uh, everything is having H1 only. So now this will become H2. This will become H2. So it has also been split. So this is also H2. So everything else is H1. Okay. So B0 had 8 and 16. So H2 is value mod 4. Okay. So it is value is how much? 8. Sorry, it is already H2 over here, na? Sorry, here already H2 is there. So this will become H3. Don't get confused. I will explain it again. So don't worry. See, I'll explain it again. This I hope you have understood, right? The first part. You will have to look at the next. See, the overflow has occurred at 4. Okay, I mean at B0. So ideally where you have to split wherever the next is pointing to. So next is pointing to next is pointing to at B0. So B0 only has been split. So B0 has been split to B0 and B1. And next has moved to the next value. Correct. So when you split, the hash function also will increase. So H0 was there for B0. Now H0 has increased to H1. So H1 is mod 4. So wherever B0 was there, whatever values were there, you will have to rehash them. So I have done 8 mod 4, 16 mod 4. Okay, and 4 mod 4. When I did that, the overflow was still existing. So, but what you are supposed to do when you split again, next is pointed to by B1. So B1 has been split. B1 has been split. So B1 was split to B1 and B3. So what happens is here there is, here there is H1 itself. Here also there is H1. Okay, mod 4. Okay, so this also will now become mod 4 only, right? So 5 mod 4 and 11 mod 4, I got this value. Now it will be, H2 itself. Don't get confused. It will become H2. H2. Okay, so H2 is, I'll erase this. H2 is, H2 is K mod 8. K mod 8. So B0, so it is 8. So 8 mod 8, which is equal to 0. So it will still be here. And the other element that we have is 16 mod 8, which is again 16 mod 8, which is 0. So again 16 will come here. Overflow was here. That is 4. So 4 mod 8 not possible. So 4 only will be the answer. Now 4, instead of being the overflow, it will come here. Okay, 5 and 11 will remain as it is. Okay, so the next value that we have is 19 and 22. 19 and 22. 19 and 22. See, 19 and 22. Okay, so once we have done one round, 2 is already over, right? Everything with respect to mod 2 is over. So what are we left with now? Mod 4. Okay, so do mod 4 on 19 and 22. So 19 mod 4 is how much? 19 mod 4 is 16 is the nearest value. So it is 3. It is 3, right? So it will come here. Likewise, 22 mod 4. 22 mod 4 is 2. So 22 will come at this place. See, this is how you can do the linear hashing. Okay, I'll do one more example. If you're still confused, let me do one more example. Okay, so first thing, I'll assume 2 buckets of size 2. So 2 buckets, 2 buckets. So this is B0, this is B1, this is next. Okay, so first it is H0 on both of them. So H0 is whatever K mod. So K mod to 5 mod 2, which is equal to 1. So 5 will come here. Correct? Likewise, 6. 6 mod 2. 6 mod 2. 6 mod 2. 6 mod 2 is again 0. So it will come to here. Then we have 7 mod 2. 7 mod 2 is 1. So 7 will come here. Okay. 7 mod 2. Then 7 mod 2. Then we have 10. 10 mod 2. 10 mod 2 is 0. So 10 will come here. Then we have 12 mod 2, which is equal to 0. So here the overflow has occurred. Overflow. And the value that has caused overflow is 12. Now what are you supposed to do? In the next step, wherever the next is pointing to, you split that bucket. So P0 is the one. where the next is pointing to. So B0, B1, B2. B1 is untouched, keep it as it is. Okay. And now next will become B1 will become next. And uh, wherever the split has happened, there H1 will be there. And this one will still be H0. H1 is whatever K mod 4. So it is 6 mod 4, which is equal to 2. Correct? So 6 will come here. 6 will come here. Likewise, you also have 10 mod 4, which is equal to 2. 10 mod 4 is 2. So 10 will come here. Then we have 12 mod 4. 12 mod 4. Now, the problem here is, okay, 12 mod 4 is slightly different, right? So this will become 0, correct? So where are you supposed to place 12? Next, 13. 13 mod 4 is 1. 13 mod 4 is 1. But if you look at this one, this is also full. So overflow. 13 has caused the overflow. So you will have to increase the bucket size. No, you have to split the bucket. So this would be B0. B1 is getting splitted, remember. B2 will remain as it is. So B1 is only having 12. B2 is having 6 and 10. B3 is the one. Now, what you're supposed to do? Okay. So here it is H1. This was previously H0. Now I'll change to H1. H1, H1. So B2, B1, whatever elements are there, on that you will have to apply H1 function. So 5 mod 4, which is equal to 1. So 5 mod 4 is 1. Okay, 5 mod. So 5 will come here. Next we have 7 mod 4. 7 mod 4 is, so it is B0, B1, B2 and B3. Okay, 7 mod 4 is how much? 3. So 7 will come here. Then 13 mod 4. 13 mod 4 is 1. Correct? So that will come here. So that is. This is how you can do the linear hashing. Don't worry. Whatever I have explained, do it step by step. Wherever the split is happening, wherever the overflow has happened, there the split will not happen. Wherever the next is pointing to, that bucket will split. Sometimes if you're fortunate, whatever overflow is happening, there only the next will be pointing to. So that only you will have to, in the next step, you will have to add one more mod and do the calculation. I hope you have understood. So in this video, we have looked at static hashing. We have looked at dynamic hashing in detail, along with the types of dynamic hashing and its examples. See, I think I have the model question paper here. See, this was last year's model question paper. In that you have one question. See, what is dynamic hashing? Explain the following techniques with examples. Dynamic hashing using directories and directory-less dynamic hashing. So you will have to explain. Okay. So I hope you will be able to watch this particular video and you will be able to learn all the things. Okay. So whatever we have learned, go through it clearly. Take up your own examples and check if the answers are coming correct. So we started with types of hashing technique. Two types, static, dynamic, its definition, its advantage, disadvantage. Dynamic hashing, what it is, its advantage, disadvantage and applications. Types of dynamic hashing, in that we had extendable hashing. We looked at the terms, what happens when the overflow occurs, and we took up some examples and we saw how to do the extendable hashing. Linear hashing also we saw, and we took up two examples and saw how the linear hashing is taking place. Okay. All the best. Study well. Thank you.